Okay, today we're going to learn about stoichiometry. Stoichiometry is the determination of how much product you can make from some given amount of reactant. So here is a helpful little flow chart. So using the mole ratio, you're able to find the mass, molecules, or moles of a reactant or product. For example, if we were given the mass of B, we would be able to find the moles of B. And then from moles of B, we can go to moles of A and find mass or molecules of A. In our real-life example, if we have 2 eggs and 1 slice of cheese, we're able to make 1 omelet. However, if we have 4 eggs and 6 pieces of cheese, how many omelets are we able to make? So each omelet needs 2 eggs and 1 slice of cheese. So we have 1 omelet here and 1 omelet here. So we are only able to make 2 omelets, but we will have leftover cheese because eggs are a limiting reactant. Okay, so now we're going to do a stoichiometry calculation. If we're given this formula, first we need to figure out what type of equation it is. And this one is we see copper is taking the place of silver in silver nitrate. So this is a single replacement equation. So now that we know that, we have to balance it because right now it's not balanced. So this is what we have right now. On the reactant side, we have 1 silver, 1 nitrate, and 1 copper. On this side, we have 1 silver, 2 nitrates, and 1 copper, so you have to balance it. First, we're going to start with nitrate because this is the one that's uneven right now. So we need another nitrate on this side, so we're going to put a coefficient of 2. So now that changes silver, so now we have 2 silvers and 2 nitrates. But now our silvers are uneven on the product side. So we have to put 2 moles of silver here, and after we do that, our equation is balanced. Now that our equation is balanced, we're able to write it out in a word or sentence equation. So here we have 2 moles of silver nitrate and 1 mole of copper. Even though there's no coefficient there, that means 1. And the arrow means react to form 2 moles of silver and 1 mole of copper to nitrate. Okay. Now we're going to do the actual calculations. So first we have our problem. If you have 7 grams of silver nitrate and an excess amount of copper, how much copper to nitrate is produced? Okay, so now we're able to solve our question. So we have our chart here that we're going to fill in. So in the first box here, this is what you start with. So we're starting with 7 grams of silver nitrate. So now down here, we have to figure out what the molar mass of silver nitrate is, so we can cancel out the grams. So here, we have our calculations. We have 1 silver, which has a molar mass of 107.868. We have 1 nitrate with a molar mass of 14.007 grams. We have 3 oxygens. 1 oxygen is 15.99 grams times 3 gives you 47.997. And added together, our molar mass is 169.872. We have 3 sig figs here because all of our numbers have 3 decimal places. So we have that many silver. Okay, so this equals 1 mole of silver nitrate. So up here we have 1 mole of silver nitrate. Then we have to go back up to our equation. So for this is where the conversion factor takes place. So for every 2 moles of silver nitrate, we are given 1 mole of copper to nitrate. So now we have to make copper into grams. So we start with 1 mole of copper to nitrate. And we have to figure out what 1 mole of copper to nitrate is in grams. So here, we have the molar mass calculations. We have 1 copper, 2 nitrates, and 6 oxygens. So this is what 1 of each is. Then after multiplying, we get a total of 187 0.554 grams of copper 2 nitrate. So now this is all set up. Our grams, those cancel out, moles cancel out, and we're left with grams. And after doing the calculations, we end up with 3.86 grams of copper 2 nitrate.
Alright, so now we're going to be doing a limiting reactant calculation, and this is our equation that we're going to be using. This is an example of double replacement because potassium switches spots with ammonium. First of all, we have to balance before we start. The first thing we have to do is put a 2 over here to get potassium balanced on both sides. So we're going to put a coefficient of 2 over here, and that makes that 2, but it also makes hydroxide 2. And now that hydroxide's not balanced, we have to go over here and put a 2 right there. That would make 2 hydroxide and 2 ammonium, and it's balanced.
Okay, now that it's balanced, we're able to write our word and sentence equation. So here it says 2 moles of potassium hydroxide and 1 mole of ammonium sulfate react to form 1 mole of potassium sulfate and 2 moles of ammonium hydroxide. Now that we have that figured out, we're able to go to our problem. So here's the question we're trying to figure out. If there are 30 grams of potassium hydroxide and 15 grams of ammonium sulfate, solve for potassium sulfate to determine the limiting reactant. So this question almost has 2 parts. First, we have to figure out how much potassium sulfate we're able to make if we have 30 grams of potassium hydroxide. So that's the first thing we're going to do. So here we have our chart. So the first thing we put in the first box is how much reactant we start with. So in this case, we have 30 grams of potassium hydroxide. Okay, so we start with 30 grams of potassium hydroxide, because that's what the problem starts with. So now we have to go from grams to grams, so the grams can cancel out. So now we have to find the molar mass of potassium hydroxide. So here's the molar mass. We have 1K, 1O, 1H. So once they're all added together, we end up with 56.105 grams of potassium hydroxide. So this all equals 1 mole of potassium hydroxide. Then we go back up to our equation, and so for every 2 moles of potassium hydroxide, we have 1 mole of potassium sulfate, because this is what we are solving for. So now we have to figure out what 1 mole of potassium sulfate is in grams. So here we have our molar mass. So we have 2 Ks, 1 S, and 4 oxygens. So once you multiply it out and then add, we end with 174.252, and then due to sig figs of the sulfur, we end with 174.25 grams potassium sulfate. Okay, and then once you multiply all this out, you end with 46.58, but due to the 3 sig figs here, we have 46.6 grams of potassium sulfate. Okay, and then in the second part of the problem, you start with 15 grams of ammonium sulfate. So for grams to cancel out with more grams, we need to find the molar mass. So here we have the molar mass: 2 nitrogens, 8 hydrogens, 1 sulfur, 4 oxygens. Once it's all multiplied out, we end with 132.134, but we have 2 decimal places here and 2 here, so we end with 132.13 grams of ammonium sulfate, which equals, once this is the molar mass, so that's 1 mole. Then we go back to our equation, and for every 1 mole of ammonium sulfate, we have 1 mole potassium sulfate, and we have for every 1 mole potassium sulfate, because now we have to go to grams, so this is the other molar mass we just dealt with. We have 174.25 grams potassium sulfate, and once this is all multiplied out, we end with 19.78. Due to sig figs, we round to 19.8 grams potassium sulfate. Okay, so now we're going to look at what the limiting reactant was. So with 15 grams of ammonium sulfate, we ended up with 19.8 grams of potassium sulfate. With 30 grams of potassium hydroxide, we ended with 46.6 grams of potassium sulfate. So the one that limits this equation would be the ammonium sulfate, because it gave us the least amount of that, of the potassium sulfate. Therefore, ammonium sulfate is a limiting reactant. Therefore, only 19.8 grams of potassium sulfate can be formed due to the limiting reactant of ammonium sulfate. So now this means that potassium hydroxide is the excess reactant, because there's more of this left over. To figure this out, we have an equation. You take what you started with minus, this is all in parentheses, what you started with again times what you could actually make. So this is with the ammonium sulfate with the limiting reactant. So that's how much you can make over how much you could make if there was no limiting reactant. So this means that we have 17.3 grams of potassium hydroxide left over after the experiment, when we could only make 19.8 grams.
Okay, so now we're going to be doing percent yield, and this is the equation we're going to be using. This is another example of double replacement. And first of all, we have to balance this. So what we're going to do is, we can see that bromine is not balanced. So what we're going to do is put a 2 in front of here. So that makes it 2 sodium over here and 2 bromine over here. And now we see that fluorine is not balanced. So we're going to go over here and put a 2 right there. That makes 2 fluorine and 2 sodium, and it's balanced. The balanced equation is 2 moles of sodium bromide and 1 mole of calcium fluoride react to form 2 moles of sodium fluoride and 1 mole of calcium bromide. So now that we know that, here's our question. If there are 15 grams of sodium bromide and excess calcium fluoride, how much calcium bromide is produced?
Okay, so now we're going to keep going with the chart. So the first box is what we start with. So in this case, we start with 15 grams of sodium bromide. So now we have to cancel out the grams down here with the molar mass of sodium bromide. So here we have 1 sodium, 1 bromine added together. We end up with 102.894 grams sodium bromide. That many grams in 1 mole. Then we go to our equation for the mole ratio. So for every 2 moles of sodium bromide, we get 1 mole calcium bromide. So now we go back down to moles, because we're going to turn it into grams. So for every 1 mole of calcium bromide, and here comes the molar mass again. 1 calcium, 2 bromine. We end with 199.89 grams of calcium bromide. And we do all the multiplication, and we end with 14.6 grams of calcium bromide. Okay. So that's what we finished with, 14.6 grams, and now we're going to find the percent yield. So here's our problem. If only 11.3 grams of calcium bromide was produced in the reaction, what was the percent yield? find percent yield, you do what you got in the experiment over what you should have gotten. Now what you should have gotten, that's what we figure out when we do the chart. So that was the 14.6 grams. So now we have our calculations. So the percent yield is 13.3 grams divided by 14.6 grams, and that will give you a decimal. To make it into percent, you multiply it by 100. So once we do the math, we get 77.4% yield, which is not a bad amount at all.